All right, so we're starting again. We're looking at some statistics, measures of central tendency. Now, this topic is not too difficult, and what I'll mostly be doing is just reading through the text. So this is something that you can do. This is nothing special. I'm going to just read through. Um, so we have mean, median, mode, and range, finding the mean from tables and tally charts, calculations with the mean, median, and mode for group data. Just reading through. Um, so in units 15 and 16, you're looking at ways of collecting and representing data. In this unit, you'll go one step further and find out how to calculate statistical quantities which summarize the important characteristics of the data. So what I'll do for you guys is to put in units 15 and 16 in the group just for some background, right? But the essence is really this, because at the end of the day, in an exam, you want to be able to calculate these things. Nobody is not going to ask you how to collect data. That is more when you're doing an SBA, really. So it speaks about the mean, median, and mode are three different ways of describing the average. So, okay, to find the mean, and they tell us, so as I said before, all I'm going to be doing is just reading and probably comment here and there. To find the mean, add up all the numbers and divide by the number of numbers, right? And we're familiar with the mean. If you have three numbers, say I have, 2, 1, and 3, right? That add up to 6. So I have three numbers, 2, 1, and 3, that add to 6, and then I divide by the number of numbers, which is 3. So 6 divided by 3 is 2. And that would just be the mean, right? And you'll see it being referred to as average. So it's the same thing as the average. So it's a simple average they describe in here. To find the median is to place all the numbers in order and select the middle number. This is very important. This part about placing the numbers in order, some people think that you can just, see some number, you just pick the middle one. No. You have to put it in order, ascending or descending. The mode is a number which appears most often, straightforward. So in a set of numbers, one of the numbers appear more than the other numbers, then that will be a mode. And so the range gives an idea of how the data are spread out, and it's the difference between the smallest and the largest values. And that's basically it. So the difference between the smallest and largest value is the range. So that's before I'm just reading through. Find the mean, the median, the mode, and the range of this set of data. All right. So notice for the mean, they just take this set and just divide it by 10, the number of numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom, done. 5.2. And notice 5.2 is not a number represented here, but 5.2 is the mean. So there's nothing wrong with having a mean that is not exactly among the numbers, right? Some people think that it have to be there. No, just follow the formula and call it a day. For the median now, place all the numbers in order. So you have this, place it in order. So 2, I say 2, 3, 4, then 5. You have a couple 5, and say another 5. So 2, 3, 4, 5, 5, 6. All right. So then we have a triple 6, not going to come in. Then 7, 8, right? And we know that. So we have 10 numbers. So it's not like you have, we know 10 is even. So you can't pinpoint a middle number per se. However, what they say is that you pinpoint two middle numbers and you divide it by 2. And that would be your median. If you had a odd numbers well, an odd number of numbers represented here, then you could just pinpoint the middle number easy, right? But in this case, you just pinpoint the two middle, divide by 2. It says right here now, for the most, from the list above, it is easy to say that 6 appears more than any other number, so mode is 6. And just like that, you guys know mean, median, and mode. Last one, range. Range is the difference between the smallest and largest numbers, in this case, 2 and 8. Right? So 2, 8, so the difference between those two. And call it a day, just like that. We're running through. A second there. All right, so we have this 5 people play golf at one hole. Their scores are 3, 4, 4, 5, 7. I like the fact that this is already in order, so it's straightforward. Mean, 5 numbers, they just add them up, divide by 5. Median, number in the middle, so this is order, so 4 is in the middle. That can pick that up easy. Score, this one mode 4. 4 appears the most, and then the range 7 minus 3, 4. And that's it, they just keep doing it. In a survey of 10 households, the number of children was found to be that, and you keep going on and on and on, on and on and on. All right, so this part now, it comes a little interesting. It says, let me see if I can find it. That's a solution, that says B. Question B, so calculate the probability that a household chosen at random from those in the survey would have exactly 4 children, more than 4 children. So this is where it gets interesting now. So let's go through. So you have all of these things. You have this survey number of children. Number of children was found to be that. So in a household of 10, well, in 10 households, these are numbers, number of children in the household. And basically, getting some statistics around it, no problem. And it's a researcher says the mode seems to be the best average to represent the data in this survey, give one reason to support. And it goes on and on and on. So to find the mode 4, right, as its frequency is highest, mean, we know all of that. Median, first put the data in numerical order, very important. 3 and 4 is in the middle because even numbers, right, even set of numbers. So not even numbers individually, but the set will have 10 numbers, so we have to be like that. The mode gives the value that occurs most frequently. So that is the reason for, the researcher says the mode seems to be the best average to represent the data in the survey, give one reason to support this statement, and their reason is that the mode gives the value that occurs most frequently. I don't know how that is a strong reason, but I'll work with it for the time being. This says the probability of 4 children. So 4 occurs 3 times. So that's it. The number of times 4 occur 1, 2, 3 times over the total number of households, right? So we have 10 households, and in those 10 households, 3 of them have 4 children. So our probability is 3 out of 10. So more than 4 children, so that means you should have, if we look at this data, let me see if I can find it in numerical order, so 5 and 7. So if you have more than 4 children, that means you have either 5 or 7 children. So this occurs, so 5 and 7 occurred 2 times, so 2 times out of 10. So this is probably the most interesting piece, this probability piece. So I would say go over this part if not so clear to you. And you can ask questions now. If this probability piece is not clear, I can go over it one more time. Cool, so let's stop me. Any questions? All right, we don't have any questions. But let me.
Sir?
Yeah?
Can I go over it?
All right, give me a second.
Can you go over that part of it?
Yeah, man, we'll do. Yeah, so for this, we're just asking ourselves, I'll make sure we go to the question itself. So calculate the probability that a household chosen at random from those in the survey would have exactly four children, more than four children. So in the survey, we'll have 10 households. So it's like you're looking at the chance of something happening within the 10 that you survey. So if you choose a household at random among the 10, what is the chance of you choosing one that has four children in the household? Well, we're assuming that choosing any particular household is equally likely. And if that is the case, then if you were to put these numbers like I raffle them, when you put them in a bag and shake it up and ask somebody to choose one of the numbers, then the chance of choosing four would be 3 out of 10 because it's 3 fours in the set. 1, 2, 3, and you have 10 overall. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So your chances are 3 over 10, right? Now, the next piece, if you understand that piece, then the next piece, hopefully understand this first piece. This part that says more than four children, if you look here, more than four, 5 and 7 are the numbers that are more than four in this set. So it's only two numbers are more than four. So that means you have two chances out of 10, really, 2 out of 10 to pick a number that is greater than 4. And that is basically what they're saying here. Oh, right? So read it over again, but that is the essence of it. So that's why they put 2 over 10. And of course, they can represent it as 0 0.2. For the top one, 3 over 10, of course, 0 0.3. All right. This part now says find the mean, median, mode, and range of each set of numbers below. So you can attempt that, right? So that is not really just do as we have been doing. The only thing to remember is to, for the median, just make sure you put the numbers in numerical order, right? So ascending or descending, and you should get the same answer. This one now, 20 students are asked their shoe sizes, the results are given, and then they just keep asking you to find the mean, median, mode, and range. So there's nothing over the top here. It's just to make sure you understand, right? They have, they say, CSXE questionnaire in a beauty contest. The scores are awarded by by 8, my bad, by 8 judges were here. Using the 8 scores determine mean, median, mean, median, mode. And then so only 6 scores are to be used. Which 2 scores may be omitted to leave the value of the median the same? Now, this is an interesting question, right? So remember, put the thing in numerical order. I have to do that. So, you know, I would start there. Of course, you would, if to do the mean, you just add up and divide. So how many numbers? Let's see. It's an 8, right? Add them up, divide by 8, you get a mean. Put it in numerical order, and then you get the median. For the mode, let me see, this is 6.7, 6.7. Yeah, 6.7 seems to be, yeah, 6.7 is the mode. And it says only 6 scores are to be used. So if you could eliminate 2 scores, so which 2 scores may be omitted to leave the value of the median the same, right? So I don't know, I guess we could probably try that. Let me see something. I'm supposed to run a little errand outside. Give me a second. All right, let me bring up my screen and see. All right, so just to get these numbers now, let me see. All right, so I can put this here, put this over here. All right. So we have, so this is the original thing, 5.9, 6.7, 6.8, 6.5, 6.7, 8.2. All right, so I'm going to step out, give me a second. All right, so put this in ascending order. So 5.9, 6.1. So help me out, you know, I think I said 6.3. And what the next one? 6.5.
Yeah.
Then 6.7.
6.7.
And 6.7 again.
Yes.
And 6.8.
And 8.2.
Then 8.2. All right. Now, by the looks of this, first of all, how many numbers we have? 1, 2, 3, 4, 5, 6, 7, 8. Right? So the median of this already. So we'll look at these two, right? And divide, add them up and divide by 2. What will we get? 6.6?
Yeah.
So 6.6 is a median. Now the question asks, let me make sure I go back to it. Which two scores may be omitted to leave the value of the median the same? Well, this is it kind of straightforward. Which number? Repeat?
So I would omit 6.5.
You would omit 6.5?
Yes, sir. No, 6.7.
You would omit 6.7 and 6.5?
Yes, sir.
You sure? Say omit 6.7 and 6.5. Then the next two numbers, when we call the median is 6.3 and 6.7. And you're going to take the average of that, and now you get 6.6.
Well, that's the closest.
Suppose you take off this number and this number.
Check those two.
If I take out those two numbers, these 6.5 and 6.7 will still be in the middle.
Yes, sir.
So the numbers to take out is 5.9 and 8.2.
8.2.
Geez, they know me do that too.
This is never too bad.
But sir, I also
I get to see.
5.9, sir. I tried 5.9 and 6.7. I tried to remove it.
We say you try removing them and what happened?
And when I did that, I got about the same 6.6. But I took out the 5.9. I took out one of the 6.7 from it. When I removed it, I said for the need, there's two little numbers there.
I'm not hearing you so clearly, Shauna. Like you sound like you're far from the microphone.
Ooh. Sir, I was saying I removed 5.9 and one of the 6.7.
Oh, that let me see. Remove.
6.7, and I ended up with the same.
Yeah, that could work too. The 5.9 and one of the 6.7 could work.
Yes, sir.
Right? So that would work, yeah.
Okay.
Well, what I would say, well, I don't expect this question to come back again, but it's easier to remove the two n numbers because you know you never the question never had to have another 6.7. This could have been, I don't know, say 6.79 or 75 or something like that. In that case, the two n numbers would be the easiest to get back the same median. Right, but of course it will still be correct. The table, next one, the table shows the maximum and minimum temperatures recorded in 6 cities one day last year. And so work out the range of temperature for Atlanta. So the range is just a difference between the highest and the lowest. Which city in the table had the lowest temperature? Which city in the table had the lowest temperature? Where, let me see, low temperatures. So we have negative 15 degrees Celsius. So this is what is Archangel. Work out the difference between the maximum temperature and the minimum temperature for Moscow. So nothing really going on here. So it's the same things over and over. Kelly had a mean score of 25 with a range of 7. Calculate Rory's mean score and range. So it's just a repeat of the same thing, right? Then it's finding the mean from tables and tally charts. Now this is where it becomes important now. Well, not so important, where you have to pay closer attention to how you find the mean when you have like a frequency table. So often data are collected into tables or tally charts. This section considers how to find the mean in such cases. A football team keeps records of the number of goals it scores per match during a season. The list is shown opposite over here. Find the mean number of goals per match. So you have number of goals, blah, 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 come down. So they say, okay, 0 goal, 1 goal, 2 goals, 3. So they have it listed here. And then they say, okay, in 8 matches, because if you read again, the football team keeps record of the number of goals it scores per match in a season, right? So in 8 matches, you have no goal. 10 matches, 1 goal. 12 matches, 2 goals, so on and so forth. So they say now to find the mean number of goals per match, this is what you do. This is the original table, so number of goals, frequency, and you multiply them. So 0 times 8, 0, 1 times 10, that, 2 times 12, 24, and you keep multiplying them. So you have total matches here, total goals. You just divide one by the other. So if you have 73 goals, and you manage to make 73 goals in 40 matches, how many goals on average you score per match? 73 divided by 40. So 1.825 goals, right? So far, so good. So a bar chart shows how many cars were sold by a salesman over a period of time. Again, find the mean number of cars sold per day. So you have your frequency chart. You put it in a nice table. The data can be transferred to a table and a third column included as shown. Cars sold daily, the frequency, you multiply them out. So your the total days, number of cars sold, how many cars sold per day, 50 divided by 20, 2.5 cars sold per day. The police station kept records of the number of road traffic accidents in their area each day for 100 days. The figure below gives the number of accidents per day. Call this up, messy man. Find the mean number of accidents per day. And it said first step is to draw out and complete a tally chart. The final column below, shown below, can then be added and completed. Number of accidents. So you literally have to be counting up these things. The number of times you say 1, number of times you say 4. One time I say 0, I say 8. One time, 7 one time, let me see if that is true. 7 one time, instead of only 7, I say, yeah. And 8, instead of only 8, I say 0, 1, 2, 3, 4. So 4 zeros. See there? So let's set it up. So this tally thing, boy, it not necessary. It just helping you to just cross off the numbers that you see. Says, okay, let's say 4, blah, 1, 2, yeah, not really necessary. There's no that 4 appear, not 4, 0 appear 4 times. 10 appear, not 10, 1 appear 10 times. 2 appear 22 times. So you just count it up, and afterwards, in a number of accidents times frequency. So 323, the number of accidents per day, 323 divided by 100. And it's the same situation over and over, right? I think let me give some more questions there. Let me see what is this. Work example 4. All right, let me see. The marks obtained by 25 pupils on a test are shown below. Copy and complete the frequency table below to present the information given. So you have this marks frequency. Use a frequency distribution. Using the frequency distribution, state the modal mark, the median mark, the range. So it says on graph paper, draw a histogram to illustrate the frequency distribution using axes as labeled below. So they ask you to draw something, and you say, all right. You look and you say 1 mark. So 1, many people press to get 1 mark. 2. So you know, say a bar will go up to 2 right here. So on and so forth. A pupil is chosen at random from the group of pupils. What is the probability that pupil's mark is greater than 5? So you fill out this frequency table. Let me see. Copy and complete frequency table below. So you say 1, 2 times, 2, 2 times, a 2 here, 2 here. So, you know, just validating what they have. You say 3, 4 times, 1, 2, 3, 4. What about 4? I say 4, 1, 2, 3, 4, 5. So right here I would have 5. And then for number of times, I'll say 5 marks. 1, 2, 3, 4, 5, 6, 7, 8. So I said that 8 times. So they complete that for us here. See there? What else? Using the frequency distribution, say the modal mark. So which one appears the most? 5 appears the most, right? See there? Median mark. What's in the middle? It's as we need the 13th number when in order, right? So 4. So it's 25 marks in total. 25 is an odd number. So the 13th mark would be the one that's in the middle. So you look and say, all right, this is what? 4, 8, and this would be carry up to 13. Right? I'm not sure if you understand what I'm doing here. So if you think about it in ascending order, you're gonna have 1 list out 2 times, because I told them you're gonna have 2 lists out 2 times. So think about it mentally. Let me see if I can represent it right here. So right, put it on a different new slide. Oh, wrong button. All right. So what have I done here? Let me put 2, 2, 4, 5. So according to this, 1 appears 2 times. So that's why I have 1, 2 times. Mark, 2 marks appear 2 times too. So I have it 2 times. 3 marks, I'm make sure I put that little thing. 3 marks appears 4 times. 4 marks appear 5 times. So if you have 25 in all, then you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Then 4 would be what is in the middle. Because if I were to continue on this, continue to do this, you would realize that, you know, 4 would be in the middle, right? So I don't have to say any more about that. But that is how they get 4 being the median. Range. So 7 minus 1, right? 7 being the highest mark, 1 being the lowest, 7 minus 1 is the range. So this now would be your chart. Notice that they put at the center of your bar chart or frequency chart as a number in the middle. So number in the middle, you put your bar, one to the left, 1 to the right, and that there's no space, right, between them. Then it said the probability that the mark is greater than 5. All right. So how many marks greater than 5? I have 6 appear 3 times and 7 appear 1 time. So I have 4 marks that are greater than 5. 6 and 7. So basically 4 out of 25, right? Since I have 25 of them in total, you know, see it here up here. You have a list of them, 25 in total. And after 25 in total, 3 of them are 6 and 1 of them are 7. So at a 4th at 25. See there? And that's where you get the probability. Then it goes on. Survey of 100 households in an American town asked how many cars there were in each household. The results are given below. Calculate the mean number of cars. So you have the number of cars. Let's say you do the multiplication. After you get that, then it's all right, that divided by that. Right? So calculate the mean number of cars per household. And you would get your answer. Because over here you get what? Let me make sure. How many cars there were in each household. Calculate the mean number of cars. So of course I go, it's a number of cars, right? So you have 70. So 70 households having one car, right? So this is the number of cars, and these are the households. 70 households having one car, 21 having two, 3 having 3, one household having 4. It's a lot of cars for one. And of course, you have 5 households not having any car. Right? And you multiply them out, and you get let me see. I'll make sure. It look like, yeah, so you do the same. I'll make sure when I mix it up. So boom, you have the number of that, and you have the frequency. You just multiply them out and divide. Right? And that's where you get the answer. That makes sense to you? Now what you're trying to do here is trying to determine the number of cars on average, right? Which is the same thing as the mean. So you can't just put this down right here, so get a number here, so, and then use this to divide it. That wouldn't work out at all. You have to multiply it out first, just like the example up top. I think I got labor too much for it. Just like the example up top, you have to do this multiplication, and then you use the frequency and divide it out. So similarly, you come, you do the multiplication, you use this and divide whatever you get over this side. All right. Same thing again. Multiply these out, they get this number, some numbers over here, add them up. And then this number get divided by whatever this is, get divided by this over here. And it happens, so it's over and over the same thing. Same old, same old. Right? All right. Calculations with the mean. I think this is interesting. And of course, hopefully next week we can, I want you guys to try, I'm going to give you guys some questions to try, and then we can look at them next week. Let me just go through these examples and then call it a day. Calculations with the mean. So this section considers calculations concerned with the mean, which is usually taken to be the most important measure of the average of a set of data. The mean of a sample of 6 numbers is 30. Well, that's 3.2. An extra value of 3.9 is included in the sample. What is the new mean? So read that again. The mean of a sample of 6 numbers is 3.2. An extra value of 3.9 is included in the sample. What is the new mean? So you have 6 numbers. The mean is 3.2, and then something happened and you add another number. So the 6 moved to 7 numbers now, and they're asking you, what is this new mean? So solution, total of original numbers, 6 times 3.2, 19.2. And hopefully you see this, right? Hopefully this makes sense here, because you can tell me if it doesn't. Total of original numbers, if you remember how the mean work, you have, so mean, right? You have the numbers, right? You have the sum of n numbers over n. So you have the sum of n numbers over n. So all these guys are doing here, they want to get to the sum of the original numbers. So just like we have sum of n numbers, so all they do is to multiply both sides by n. That's all they do. By doing that, you get n times the mean, which is equal to the sum of n numbers. You watch the handwriting. So that's all they do. So in this case, you have n numbers. In this case is 6, and the mean is 3.2. Multiply the two of them and get the sum of n numbers, right? They call it total of original numbers. No problem. So this is 19.2. And what you do to it now is to add this extra number to it. Or is it 3.9? So you have 19.2, you add the 3.9, you get 23.1. And you move from 6 numbers to 7 numbers now because of this extra number. You divide by 7. That's where you get the 3.3. The mean of a set of number, well, the mean number of a set of 5 numbers is 12.7. What extra number must be added to bring the mean up to 13.1? So again, total of the original numbers, 63.5. Total of the new numbers, right? Because they want you to bring it up to 13.1, right? So if you were to add, and they want to add a number to bring it to 13.1. So if you add a number, it's going to move from 5 to 6. And then the total of the new numbers can be 6 times 13.1, which is 78.6. So that number that would carry it up to 78.6 would be 15.1. So that's all they do. They say, all right, the total of the original set of numbers, which is 63.5, you take the difference between that and the new total, which is 78.6, and that would account for what the extra number should be, which is 15.1. So, let me see what else I have. So this is the last one I'm going to look at, and I'm going to drop this sheet in a group, and you guys can look at the rest for yourselves, right? So Rohan's mean score in 3 cricket matches was 55 runs. How many runs did he score altogether? So mean score in three cricket matches was that. How many runs did he score altogether? So they want you to find the total, which is just 3 times 55. And it's a 165 runs down here. After 4 matches, his mean score was 61 runs. How many runs did he score in the 4th match? Similar, very similar to the question here. Up top right here, so we'll ask, what is that extra number? What extra number must be added to bring the mean up to that? Same idea. So after 4 matches, mean gone up to 61. So 4 times 61, 244. You take the difference between what it was before with the old mean of 55. So the total before was 165. You take the difference, you get 79. So the 4th match score must be 79, such that when you add up the original numbers to the 79 and divide by 4, you get the mean of 61. And here are some questions. You can do them. So I guess next class we can look at this down here, group data, and see how it works out. But yeah, I think that's enough for the day. I'll put the homework. I'll specify the homework in the group. I'll put this and specify, but I would say do as many questions as possible. I'll also put an answer sheet for this topic in the group as well, so you can check your answers. And of course, I do have to wait on me to specify what a question to do exactly. Just attempt as many as I can so that the concepts stick, right? And that should be good enough. So until next time, take care. Hello?